think we're going. Yeah. Yeah, we're set. Okay. All right. So now, one of the things that we're going to talk about now is relationships. So when we're dealing with relationships, I'm sorry, messing things up here in my notes. Okay. So when we're dealing with relationships in Swift data, uh, there are a lot of kind of hidden rules about automatic relationships that Swift data sets up for you, where you don't necessarily have a desire for a inverse, a bidirectional binding to exist where it will create one, okay? These rules are vaguely esoteric and hard to distinctly remember. So rather than tell them to you precisely, I'm going to recommend just, look them up when you need them because they're kind of annoying to remember. But essentially, it's basically like if on one side of the relationship, one of your properties is optional or both are optional, it will try to automatically set up the relationship for you. But if they are both non-optional, no relationship gets set up, and you have to set up the relationship manually. Okay. So a great example of how that can kind of bite you in the ass is here. So let's go ahead and take a look at our very simple trail view here that we've got. Now, don't forget, we just added this concept of a next trail, right? Where we want to be able to have another trail that we go to, okay? And then that trail, presumably could link to more trails, or it just stops and doesn't link anymore. So one thing I wanted to do was make it so that if we don't have a next trail, then the user can choose to make a new one. So we'll go to a new empty trail that we create, and then we will save, right? If the user hits save, okay? So I added this very simple if let, right? And when I tested it, I ran into a super fun surprise. Could anyone hazard a guess? When we go to Snake Ridge Part 2, what will the navigation link say in its title on the Snake Ridge Part 2 screen when we click on it? Make next trail, right? That's what you'd expect, right? There's no, when we define it, we're not giving it a next trail, right? Its next trail is being set to nil, right? That's happening here, okay? So here in our preview, right? We go to Snake Ridge Part 2. And it has a link to Snake Ridge. This is because it set up a two-way binding. A two-way one-to-one binding from trail to itself. From the trail type to itself, okay? So we didn't talk too much about relationships where one type points to itself, but it works basically the same way as one type pointing to other types, right? So this happened because on trail, we have this. Trail is an app model, okay? And the app model type, we have another app model type here, trail, right? Optional trail, as a parameter or as a property, right? Because this is a property here, this is a relationship. Because the type that this property has is a model. So if anything has app model and is a property, Swift data will try and set up a relationship if it can. And in this case, because it's optional, a relationship gets set up. Now, if we make this non-optional, we'll get a bunch of errors saying, oh, you need to set one, right, everywhere. So we're not going to do that, right? Instead, what we can do is tell Swift data, hey, chill out. We don't want a relationship set up here, okay? In order to do that, you use the @relationship macro. And it has a ton of things that you can say, but the one that we care about is inverse, okay? So in order to say inverse here, to say we don't want a bidirectional relationship, we do not want the you know, like the property that has our type on that other type, which of course is us. So any property that has our type on that type, right? We don't want that to be set up automatically to point back to us, right? We don't want to have you create all of the meta data to like say, hey, if we set this trail as the next trail, then we also become its next trail, ha 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 ha, right? Which is exactly what it's doing, right? So here we just say for its inverse, we say nil, okay? Great, awesome. So now when we go back to trail view, and we look at this, now that we've broken this relationship, it's complicated. Now it will say make next trail, and we are now able to make another trail. But other than the nav stack stuff, it would be kind of cool to kind of be able to traverse back and forth across multiple trail segments, right? You know, Snakehead Part 1, Snakehead Part 2, Snakehead Part 3, right? So maybe we do want to have a way to kind of have a way back, right? So what you can do, if you want to basically recreate the linked list data type, right? Which, you know, usually doesn't show up in real life. Linked lists are primarily in the head of like computer scientists, and that's it. You can set up a relationship called previous trail that points to any other trail's next trail. And then you can also have next trail be invertly related to previous trail from the next instance. So they point back to each other. So we can say inverse slash, because it's a key path, and this one is going to be next trail. So the trail who is the previous trail, the instance that is the previous trail, we are going to set up a two-way binding between our previous trail and their next trail, okay? And then here, we would do the reverse. Now, this will give an error, and the reason it gives an error is because Swift data really prefers that when you set up a relationship, you only use the relationship macro once. You don't use it on both sides of the relationship. You only use it a single time, okay? So here we're going to just, you know, do this. We're gonna have it just be on next trail, okay? Cool. All right, so now that that's set up, right, let's go back to our view and let's go ahead and add another navigation link, right? And it'll be set up very similarly, where we'll say if let previous equals trail dot previous trail. Then there will be a navigation link called previous dot name with the value of previous. And then we won't have an else because we don't actually want to have a make next trail or a make previous trail button. We want it to be just something you kind of keep adding on, but you can't like go backwards, right? That would be kind of weird. So now, because there is no previous trail on this trail that instance that we're looking at here, there's no navigation link because we didn't have an else here, right? So this just gets skipped. But if we go to Snake Ridge Part 2, then we have a thing to go back to Snake Ridge. Now, of course, we all know this isn't going to go back to Snake Ridge. It's going to push a new Snake Ridge instance onto the stack, right? Which just kind of starts to get, you know, sort of weird, right? And kind of fucky, but you know, that's fine. We kind of, you know, you would probably prefer to set this up in a way where like you're just expecting them to go to the previous trail by backstacking, right? But if somehow they get to the second trail from, say, that outer list and they want to be able to go to a previous trail, this is how you would do it, okay? But that said, I think that you'd want to do some more like navigation path modification rather than pushing over and over again. You'd probably prefer to say, oh, cool, if they're going to a trail, get the entire list of trails that, you know, that chain together and then chain all the ones in front so that when they hit the back button, they go back to the previous one, right? That's probably what you would do. I don't know. I'm not a UI UX designer, clearly. Okay, I'm just an app developer. Okay, okay. So that's relationships. That's kind of how you set them up in between types. Here we happen to be setting it up in between this type and itself, but the rules apply in exactly the same way if you were using a different kind of app model. All right. Are there any questions about relationships in Swift data? Here, this is just a one-to-one. There are, as we talked about before, one-to-many and many-to-many relationships, but they behave in very, very similar ways. Cool. Okay. All right. So, I want to talk now about separation of concerns and setting up your, architecting your application in a way that isn't going to set you up for failure in the future, okay? Basically, when you're building an app that has both persistence and a networking layer where you're interacting with an API or some other form of getting data from the internet, from the network, you have a few things that you need to consider when you are getting that information, displaying it to the user, and persisting it to your local store, okay? You have to think about what things are going to be marked as just state variables on views, what things are going to be observable objects that don't get persisted, what things are going to be, or sorry, not observable, observable types, at observable types that are going to not be persisted, and what are going to be at model types that do get persisted, okay? Another thing to consider is that using Codable, the Codable protocol with model classes is a pain in the ass. So for example, if we were to make this Codable, right, first thing it does is it yells at us. It says, oh, that does not conform to decodable, right? And in order to do that, you need to be able to do this, right? You need to have this initialized that comes from a decoder, okay? And then it's like decoder dot, where is it? Container keyed by, and then there's this coding key type, right? And you need to create a enum called coding keys that comes from the coding keys type. And this has all of the keys that you want to code and decode to, right? So this would be, oh, cool, okay. So we don't get previous trail or next trail from the backend, let's say. Let's say that those are things that only the user, sets up, okay? In a world where rather than creating trails, they're just linking them together, right? They're creating a plan for what trail to do after the other in their mind, and the API you're using doesn't have that information. All it has is the name and the length, right? So you're trying to set this trail up so that you can put directly into when you decode your JSON from your API, you can decode directly into your trail class, right? So that you don't have to have a bunch of different things, right? Makes sense, feels intuitive. Swift data fucking hates this, okay? And that's when you do Codable like this, you have to completely implement it by hand because this is a class and not a struct, and you cannot have structs that are at models, okay? So in order to implement this Codable, when you're not getting it auto-synthesized for you by a struct that is full of other codables, you have to do this. You have to have this init from decoder. You have to define coding keys for each property that you want to code and decode to, right? So this would be case name and case length. But it turns out you called it length because you're a sane person, right? But the API, for whatever reason, called it length in miles, right? Like that. So you need to set this up, right? And then you need to make this a string, right? And then here now you can say, okay, coding keys like that, right? Dot self, I think, no. Right, needs to throw like this. self, like that, right? So now you have this container, okay, and you can say decode, and you can decode, let's see, we've got a string dot self for key dot name, right? And now we say name equals this, right? Oh, we also need to try this too because it can throw in case anything went wrong with our specification. And then we have our length, right? Try container dot decode double dot self dot length, right? Okay. And now we still don't conform to codable because we need to be able to encode, okay? So now you have to create an encode to function that does this in reverse, right? So you need to take your encoder and you say, you know, container keyed by var container equals container keyed by coding keys dot self, right? And you do container dot encode, and you pass in, here we'll do name for dot name, dot encode, length for dot length. Okay, cool, right? And it needs to be able to mark as try, okay? And so now you have implemented coding codable, okay? So now you can get from JSON straight into this model. But let's say that you decide you want to, you know, the API has a bunch of other fields that you weren't using and you decide you want one, like elevation change, right? Okay, well, if I want this in my JSON now, right? Okay, well, first of all, I need it here, right? So it'll be elevate, you know, in my initializer, right? This is kind of a pain that I have to do this, but whatever. Elevation change double, we'll make it nullable because, you know, it's new and we're adding it, we're technically breaking the API, right? You know, and all that stuff. So, but for now, we'll get rid of that. But, right, you do still need to like set it up here in the decoder, right? So you'd need to add another case, right? And you'd need to add another decode and another encode, right? And anytime you change the model, anytime you want to pull something new or get a different thing from the JSON, you need to change all three of these locations in addition to anything else you need to change in your code. It's just a lot of boilerplate. It's a real pain, okay? It's much better, typically, instead, okay, to have something like codable here. Okay. We'll keep it simple. All right. So trail data. Okay. So create a protocol that specifies these things. Right. Right. We need to do a get. So okay. And then put the extension, right, on your protocol. Okay, and we can, and then call this something like you create a function that can transfer from one to the other. Well, actually, hold on. Okay, I'm getting ahead of myself. Sorry. So okay, so we've got our protocol. Cool. Okay, so now we have trail data. All right, like so, right? Not this. Okay, so now we're implementing. We're conforming. We just adopted this protocol. We kind of already were conforming to it, but now we're conforming to it again. Huzzah, right? And then you can have your trail data transfer object. Okay, now a data transfer object is a fancy term. DTO is another way people say it for a model that is used for transferring information from one place to another, typically over a network. All right. So frequently, the way people will model things in their apps is they will have DTOs that they get down that are codable structs they get down from the network. Right. Then they'll have their app models that are their persistence layer, and typically that app model will bind to Swift UI, and that's kind of all you need. Those two things. But If you're also having some Swift UI stuff where you're having to add a lot of at state and a lot of at binding, properties to your Swift UI stuff, even though you still have these at models, for situations where you have objects you don't want to persist or types you don't want to persist, then those would be view models, for example. So you'd have three kinds of models in your app. You'd have your DTOs, data transfer objects, or you could also call them JSON. Some people do that to just be kind of cheeky. They call it, trail JSON, right? Or like trail JSON encode, encoder or encodable or codable, right? Or just like trail codable, right? You could call it whatever you want, right? I tend to, just go with like DTO, right? Whatever. So this is codable, trail data, right? And now we just do var name string, var length string, double. And the other thing too is because app models need a lot of their stuff, they need their stuff to be variables. If you make this a let, it will yell at you and say this is an error in the Swift 6 language mode, which I forgot to switch to when I made this new thing. So let's go ahead and do that real quick. Go to build settings, search for Swift, change from Swift 5 to Swift 6. I wish I could make that default somewhere, but I can't. So if wishes were fishes, am I right? So if you set this to let, you'll get an error, right? App model types need their properties to be vars because by definition, they are writing to and reading from them all the time from the persistence layer. That's why you have it marked as at model, right? You don't want a constant in your model, right? Sometimes you might, right? But like, in that case, use a computed property, okay? So you can have like computed double, right? And this is, I don't know, length times 2, something like that, right? Cool. Now this is immutable, right? No one can change this. It's always length times 2, right? That sort of thing. So, anyway, so back to this. So we've got trail DTO, right? We have trail data, okay? So now we want to be able to basically pull down a bunch of trails, display that information, and then start to make modifications, right? And what this ends up kind of looking like is you'll still have to create some sort of transference method, but it's much simpler, right? Where you say, oh, cool, okay, taking a trail, initialize from a trail, right? Taking any trail, okay, right? And then say self.name, or we can just say name because there's no equivalent. Trail.name, and then length equals trail.length, right? No concrete type trail. Well, trail data, sorry. Any trail data. And so, yes, we're having to make this initializer, but this is much nicer than making an initializer, an encoder, and a decoder, right? We're getting all of that for free here. And we've also now separated the concern of talking with the network, which is done by our DTO, and persisting to the data model, to the data layer, which is done by our model, and binding to the views, which is done by our at state properties using these at models in the Swift views. So it's kind of separating things out a little bit. And that's kind of considered how you go about doing sort of best practice breakdown of your data stuff in Swift data and Swift UI. One other thing I want to show you is environment. We haven't really talked a lot about environment. I used it just a second ago in the previous little segment, I think, where here, this at environment thing. So environment variables are a way for you to inject a observable type down the entire view tree of a particular view. So you'll note that we have this model context here. We set var context model context, but we never do equals model context anywhere, right? like with an initializer, right? You know, with a name or whatever, right? Like we don't do this anywhere. This hasn't been done once, right? And that's because the context is getting created by this helper mod that creates the container and the context and all that stuff, right? And this is passing it in and everything, okay? So let's say that we want to create a type of, like a special type of default trail that exists for all of our views on the app. Just we want to be able to access it from all views. We want to be able to change it in any view, like in the code, and then have it be changed elsewhere, right? I don't know why you'd want that with a trail. It's a terrible example, but it is what it is. Actually, let's do a. How much time do we have? Okay, I'm gonna try and do it with a favorite list, and we'll see what happens. Okay, so yeah, so let's create a favorite list. Now, because we want this to be an observable type, okay, we need to make this a class. Also, you'll see me use final class very frequently without observables. That's considered best practice. Final makes it so that the class cannot be subclassed. Someone cannot inherit from it, right? Because then they could use polymorphism to mess around with your database very strongly, right? So it's considered best practice. There are times when you don't need it. There are things that you might want to do where subclassing is involved, where you don't want it, but for the most part, you can use final. We'll call this favorite list. And we're using a favorite list because we need this to be hashable and identifiable and all that other stuff. And an array is not identifiable, I don't think. Well, you know what? Okay, let's try it. Let's try it with an array first, and then we'll use the favorite list observable if no, because an array is a value type. It won't work. Okay, sorry. I'm just they might do some stuff. We're gonna try it. We'll see. Okay, sorry. I know I'm all over the place here. It's what you get with the live figuring stuff out. All right, so let's go ahead and call this favorites. All right, it's an array of trails. Okay, it starts out empty, presumably, right? But to start with, we're going to just give it something to start with, right? So we're going to call this my fave. That's my favorite trail, and it's 100 miles long. Okay, whatever. So now we have this array of trails, right? You can then inject this down to all of the views inside the window group by passing it down as an environment object, right? Okay, so it does need to be an object, right? I'm pretty sure environment value v. Okay, yeah, but what is type v? Hold on. We're gonna quickly look at their API here. All right, where does v come from? It's just generic. Okay, so there's no constraint on it. Perfect. Okay, cool. Okay. So the key path. Oh, I see. Writable key path environment. Okay, got it. Okay. We're not going to do that. That's too complicated. All right, so if you were to do environment like this, and you were to try and pass it in, with just an object, right, like this. If you did favorites, it's going to give you a compiler error. And that's because environment requires that trail be a class type. An array of trails is a value type. Arrays are value types in Swift, right? So we're going to need our observable final class favorite list, okay? And this is going to have a variable, or it's going to have a variable called favorites, and that's going to be the type that we want, right? We're going to do all that same stuff, okay? All the same things, right? Cool. Okay. And then we need to do the thing where we make it equatable, right? And so, we do this, left-hand side equals, right? And you can say like LHS dot favorites dot what is it? Elements equal other, right? Whether the sequence and other contain the same elements in the same order. That doesn't actually compare the value of the elements unless you do that specifically with a by, right? So you can do RHS like this, and then dot, and we'll say trail. Nope, trail, please, lowercase, right? And then, well, actually, we'll call it just left and right, okay? And then left equals right, because our two trail types are the same, and it's yelling at me. Other sequence, favorite list, blah, blah, blah. Conforms to sequence. Right, it does. Okay, cool, whatever. You can, instead of being fun about it, I guess, you could just do for left side in LHS.favorites if do this and what is it? Index on this side, I think, like that. Favorites.enumerated gives you the index as well, so that you can then do RHS index equals left side, or is not equal, then we return false, right? Something like that. RHS has no subscripts, right? It's RHS dot favorites, right? Like that. Something like that, right? You can do that to compare everything in. But because they're value types, I think you can also just do favorites equals RHS dot favorites. And it compares. And even though the reference is inside, it's comparing if it has all the same references, right? So we're still not conforming to hashable quite yet. Because we need to also implement the hashable hash into function. So this will just be hasher dot combine favorites in there. Now we're hashable. Okay. So now, of course, favorites isn't defined, right? And that's because we need to define it. So this is going to be favorite list equals favorite list, right? I guess you actually don't need to define the type when you're doing an equals like this, right? This can even be, well, yeah. Okay. So now this has been passed in to the environment, which means any view that is within this window group, including anything within content view, right? Including any view that's within content view, other views, right? So, so all the way down to trail view, we can now pull this out of the environment. So we could go, at environment, right? Slash, what is it? It would be array of favorite list. Sorry, not array, just favorite list. Sorry, favorite list, right? Like this. Dot self, I think. Like that. No, is it really? Do you pass it in? No. Oh, well, let me hold on. Okay. Favorite list. Like this. Right. Okay, it is dot self. Cool. Of course, now it's giving us all sorts of problems because it's looking for something on the environment that hasn't been passed in to the preview, right? So we need to now do like, oh, okay, so it's favorite list like this, right? And now it should have less of an issue on this screen. Yes, good. So now we have access to this favorite list reference, right? And any other view that gets this environment passed down to it or injected to it, if you will, any changes we make to it will be applied elsewhere, right? Because it's being observed, because it's that environment on an object or on a class type that has been marked with observable, right? You can also make this a model if you really wanted, right? And do all sorts of weird shenanigans with that, but that's a different story. Are there any questions about at environment and dot environment and how that gets passed down and used and whatnot? Cool. Okay. Last but not least, there is a sort of open question with SwiftUI in the development community about where do we actually create and store and kind of like start our data and our like work that is not related to views, right? The things that aren't specifically view related, right? Because everything that you do in the view stack that starts here in var body, right? So far, everything we've done is pretty view centric, right? But like creating a networking client that we then use, right? Where do we do that? Do we first do it when we first need it? Do we do it at the very beginning and pull down while we're loading in the background? Probably a good idea if you have a bunch of stuff you need to pull on the network, right? But you can't do that unless you like tie it to loading at a specific view, right? Currently, from what we know, right? The answer to that ends up being both complicated and very, very simple. So let's say we have a network client, that we want. We're going to make it a class because we only really ever want one of them, right? We're going to have it be shared, okay, network client like this, right? And then this is going to be set to, sorry, it's a let, not shared. It's going to be network client like so. Then we need an initializer, right? And this is not concurrency safe because this isn't sendable, right? So you make it sendable, okay? And it's unchecked, right. Okay, sorry. This should be a struct or an actor. Actually, it should be an actor, sorry. I turned on Swift 6 mode and all of a sudden forgot everything about concurrency. So this would be an actor, right, that is not sendable. That's okay. And now you want to be able to basically call it anywhere, right? This pattern where you have a type with a static shared property on it that gets instantiated at the very beginning and cannot be modified, right? And that you would presumably define with a private initializer so that no one else other than this class is allowed to initialize itself. So this is the only way to ever make one, right? This is called the singleton pattern. You use this whenever you only ever are going to have one instance of a type ever. And you want to be able to access it from everywhere in your application, okay? It's the singleton pattern. It is one of the most abused and overused patterns in programming, period, by people who are new, by people who are mid-level career, and by people who have been doing this for decades, right? All of us don't use this exactly really how it should be. We use it way too frequently. It's so easy to reach for it and grab it and use it that sometimes it's very tempting. The problem with singletons is that what that error was telling us before we made it an actor, right? Which is that it's not concurrency safe. Singletons are not thread safe. They are a form of shared global data state. You can access them from everywhere in your application, and you can change their data from everywhere in your application. Now, if your singleton has just got a bunch of like static methods on it that you just call, you don't need a singleton, right? Singletons are only required if you need to save some data, not necessarily to the store, but in memory, right? But for example, if you just wanted to have a bunch of, I don't know, functions, right, that, hit the network, right? So you'd have like, get trails, right? Returns a trail, right? Or an array of trails, right? And this is all the trails at your REST endpoint, right? And here we're just going to return an empty array just to get it to go, right? And so on and so forth. And you don't need to store any information in the network client. You don't actually need a network client instance ever, right? There's no data that you want to keep stored anywhere. You can just make these functions static. And then you can access them by doing network client.getTrails like this from anywhere, right? You don't need an instance. You don't need .shared. You do need .shared, like so, if you have something like a cache, right? Like this, okay? Where oh, cool, my cache equals, whatever, I get from the network, right? Load from network, store to the cache, and return the cache, right? And you can then also say, if cache is less than like 5 minutes old, right? I'm obviously writing pseudocode here because writing this actually like in real life would take a little bit longer than we have. So if cache is less than 5 minutes old, then just return cache as it is. Don't load from the network. Don't hit it, right? Just don't go there, okay? So, but this is a form of state, right? And it's a form of shared state, right? So you end up in a situation where now this isn't exactly type safe. So making it an actor helps a lot with that, okay? Of course, then you run into other issues where now you have to await get trails whenever you call it. But you should have been doing that anyway. You should be awaiting most things that are taking a long time, like a network call, because it's asynchronous, and you want to be doing it at the same time as rendering your view and showing your nice spinner. Remember, the spinner is everything. I didn't put it as a requirement in the like final project thing, right? That a spinner be in your final project. So it's not a requirement because I'm not going to change the requirements on you. But if you put a spinner in your final project, it will make me very happy. It will make me smile. So please do. Obviously, if you don't worry about it. It's not. I'm not going to take points off. But it would make me smile if I saw a spinner. So, okay. So you could make your functions just purely static, and then they just work, without any issues. You could have a singleton that is an actor so that you are concurrency safe with your singleton, right? Cool, okay, that's 2 ways of doing it, but is there nothing else? Do we have no other options, right? The best other options we have with Swift UI is creating environment objects that we can pass down, right? We could have our top level, thing have we could have this, have some sort of at state var app state, right? And you could create an observable app state type, right? And then that holds a lot of your, high level state information, including how to load other state. It might not store it within itself, but it knows how to get it, how to hit the network, how to hit your local store, how to pull that stuff in, right? And then you inject that into your content view, and then from there it does some stuff, right? But because Swift UI uses a declarative style rather than an imperative style, it's a little bit kind of noodlier about where you put these sort of longer term things that you want to exist. The main thing to know is if you want your data to continue to exist in memory, but not necessarily persist to the store beyond the lifetime of any one given view, whether or not it's being used by the view or not, make it a class and make it at observable so that you can observe it if you need to observe it in the Swift UI view, right? If you have some set of classes that you want to exist and have be running, alongside all of the views in their own actor, concurrency domain, and it's just Bitcoin mining while your user is, doing stuff, right? And you just have this whole other stack of information that's not interacting at all, right? You would set that up in your app, in your Hiking Trails app's initializer, right? So you'll note there's no initializer defined here, right? But you can make one, okay? And in here now, you can write normal non-view code, right? So you can say, have like, please don't do this, by the way. Don't farm Bitcoin on your users. Like Apple will reject your app. They will automatically reject your app if they detect you doing this, and they are very good at detecting these things, right? But like as an example, right? If you wanted to be running a bunch of background tasks in the background that are completely unrelated to any view events, they have nothing to do with the view except for the fact that they like update models that get used by the view, maybe within your persistence layer or something like that, right? But you have a bunch of background stuff that's working. Yeah, instead of Bitcoin farm, let's just call this, I don't even want to put that energy out there, because Apple might come down on me. like background work, right? You'd have your actor background work like this, right? Um, and then it, from within here, you can have its own, it has its own initializer, right? That starts a bunch of stuff. And then you have a bunch of other types that you're using and functions and whatnot, right? That are just doing their own thing, kind of kicking off and running, right? Um, that then can be created here, right? Where you do background equals background work like this. And then if there's like a, if you want to have like a run loop that's running at a certain like, refresh rate or something, right? So you have like function run, right? That like this kicks off a, I don't know, like a frequent, repeatable set of tasks. Like, oh, okay, every like 10 seconds we want to upload any metrics that we grabbed or whatever, right? Something like that, right? And we'll make this async, right? Because it should be. Now in here, now that you've created background, you would kick off a task, an unstructured task to start with. Typically at the very, very top level, you're going to start with an unstructured task almost always, right? So create your unstructured task. You'll call background dot run, and you'll need to call await on that, right? And it mutates self, and that's true. How do we get around that? We do weak self in like that, and then self question mark dot background run. This is, it's a struct, yeah, so we can't weak it. Okay. I'll make sure I'll figure that out. I'll send a correction, lecture correction on this one tonight, because this is something that I know you'll need to, or you might not need to be able to do it, but I know the way my brain works, SwiftUI's approach of, don't worry, you can just have everything be related to views, and you don't need to be able to do stuff like this, and you don't need to be able to have an actual set of imperative programming that you're building on the side in addition to it. I'm distrustful of that. I believe that you will often find cases where you need to not be related to views. So I don't want to keep you too long, so I will figure out exactly how you call self.background run here, because there is a way. I just do not recall what it is off the top of my head. But yeah, you can kick off this task, and then typically you'll also, as a part of like app lifecycle stuff, you'll want to have like a task type that gets set here, so that you can control that task from other views and stuff. You can inject it as an environment, object, and then, modify it, and you can cancel it when you need to and start it again and that sort of thing. So, okay, cool. Any questions about this kind of, entry point stuff for SwiftUI and Swift Data? Cool. Okay. I didn't quite get into as much as I wanted to about like kind of high level architecture, structure stuff, but we covered some. So, all right.